Problem 78. Benzene has a heat of vaporization of 30.72 kilojoules per mole and a normal boiling point of 80.1 degrees Celsius. That normal means 1 atmosphere, 760 millimeters of mercury, or torr. Right, all the same. Question is, at what temperature does benzene boil when the external pressure is 445 torr? So I have delta H, I have vapor pressure, I have two temperatures, two pressures. I'm looking for one of the temperatures, but I have two temperatures and two pressures. So that's going to be the Clausius-Clapeyron equation, two-point form, where I use natural log of P2 over P1 equals negative delta HV over R times 1 over T2 minus 1 over T1. Okay, and we're looking for a T. It doesn't matter what T. Alright, so I'll look for T1. I'm going to say T1 is my question. So that means P1 has to be there, and the 2's are here and here. Okay. Alright, and we know what delta HV is. Perfect, right there. Alright, and we know R. Okay. So again, depending if you want to do a lot of algebra or not, let's try to do the algebra. So the first thing I got to do is get this number, delta HV over R, out of here. I can do that, can't we? Alright. So, we'll do it both ways. Alright. So I'm going to get the natural log of P2 over P1 times, I'm going to make it negative, R. I don't want it on the outside. There we go. All over delta HV. Well, I do. Delta HV. Alright. Now I have equals 1 over T2 minus 1 over T1. Alright. So, now I have to get T1, right? So I have to move the 1 over T2 to the other side. So negative natural log over P2 over P1 times R all over delta HV minus 1 over T2 equals negative 1 over T1. Multiply everything by negative 1. Boom, boom. Alright, now I got T1 on the bottom. I don't want T1 on the bottom. I want T1 on the top. So we can just invert everything, if you're okay with that. Alright. Which would be, alright, well, you multiply both sides by T1 and divide. So I get 1 over natural log of P2 over P1 times R over delta HV plus 1 over T2. Alright. That has to be done first. Equals T1. Alright. That sounds fun. That's a lot of fun. Alright. So, I get 1 over natural log. P2 happens to be 760. So 760 torr all over, what was it, 445. Right, that number times 8.3145 times 10 to the negative third kilojoules per mole Kelvin. Right, divided by delta H, which was 30.72 kilojoules per mole. All that math has to be done, and then we're going to add that to plus 1 over 353. Oh, we didn't change those, did we, in our problem? So 80.1, I have to add 273 to this, don't we? Right? And so 80.1 plus 273, or 273.15 if you feel inclined, I get 353. I'm only going to have 3 sig figs in my answer anyway, so 353 Kelvin. Well, let's use that. There we go. Okay, and then all that is, well, let's do parentheses here, equals T1. Alright, or you can start plugging in the numbers. So natural log P2 is 760. P1 445 torr equals negative delta H over R 0.3145 joules per, times 10 to the negative third, almost forgot, kilojoules per mole Kelvin. Oh, why did I put parentheses there? Put parentheses here. Alright, delta H is, we had 30.72 kilojoules per mole, and T2 353. T1 we don't know. Alright, so the first thing you have to do in this way is right here, natural log. So you type in natural log of 760 over 445. So ln 760 divide 445, and you get an answer, 0.535. Alright, so 0.535 units are gone. Equals negative, I still have R over here, 8.3145 times 10 to the negative third kilojoules per mole Kelvin. I have 30.72 up top still. .353 and T1. Alright, so now coefficients here have to go away, right? I have to multiply by, I have to bring 8.3145 up and the 30 down. Alright, so I'm going to take R up, delta H down. If we do that, so I'm going to take that number right there times negative 8.3145 times 10 to the negative third. Oh, whoa, wrong. Second E, negative 3 divided by 30, right, 0.72. I get negative 1.448 times 10 to the negative 4. I'm adding a sig vig. We only have 3, but I'm keeping more. So negative 1.448. Negative 1.448 times 10 to the minus 4. Right? And that's 1 over Kelvin. Kelvin's still on the bottom. Kilojoules is gone. Moles is gone. Kelvin's on the bottom. Alright, equals 1 over 353 Kelvin minus 1 over T1. Okay. Now I have to subtract 1 over 353 Kelvin from both sides. So if I subtract, I would just minus 1 divided by 353 Kelvin. And I get negative 0.002977. One over Kelvin equals 1 over T1. Now, multiply both sides by T1. T1 times negative 0.00, well, this is a negative, 0.002977 1 over Kelvin equals negative 1. So then T1 will equal negative 1 divided by negative 0.002977 1 over Kelvin, which would be negative 1 divide my answer 335.8, so 336. 336 Kelvin, or now did the problem ask for Kelvin? It's just temperature. That's fine. But if we wanted Celsius, I would subtract 273, correct? Minus 273, and I get 63 degrees. Celsius. All right. Now, doing it this way, over here. All right. How do I do all that in the calculator? Well, that's fun, right? Because you might like, whoa. So now you got to do it. Maybe our calculator skills will be tested. We'll see. So 1 divide. Open a parenthesis up. All right. Okay, I have to open 1 up, and actually I'm going to open 2 up. Okay, I'm going to do natural log of 760 divided by the 445. Alright, close that one. Alright, now I got to times it by 8 point, that's a 3, 8.3145 times 10 to the negative third, and divide by 30.72. Alright, and that's the first term. Close. Alright, and then we're going to, hold on a second, let me go back here. Yep, we're going to add 1 over 353 plus 1 divided by 353. Close the parenthesis. And I think that's it. There you go. 335.8. Same answer. So again, it's up to your calculator preference. So it doesn't matter to me which one you use. It matters to me that you use it correctly and can figure it out. Okay? Alright. So being able to use your tool is kind of important. So that is how we do 78.